Hello viewers, welcome to Elimu TV, where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 3. Our lesson number is 30. Our title is Total Internal Reflection. Objectives of this lesson: to investigate the relationship between angle of incidence in glass and the angle of refraction in the air. The relationship between the critical angle and the refractive index. Okay, what is the critical angle? It is the angle of incidence in the denser medium for which the angle of refraction in the less dense medium is 90 degrees. The critical angle is the angle of incidence in the denser medium for which the angle of refraction in the less denser medium is 90 degrees. Next. So, what is total internal reflection? Since it is not possible to have an angle of refraction greater than 90 degrees, when the angle of incidence exceeds the critical angle C, there is no refraction, and all the light is reflected internally within the denser medium. The laws of reflection being obeyed as shown in the figure. As you can see from the diagram, the laws of reflection are obeyed, whereby we have the incident ray and the reflected ray, we have the angle of incidence and the angle of angle of reflection. And as you can see, that is total internal reflection. Yeah, because we cannot have an angle of incidence an angle of reflection that is in the less dense medium. It is 90 degrees. There's no refraction when we have an angle of refraction greater than 90 degrees. So as you can see there, that is total internal reflection, because we expect that ray to be refracted, but it has not been refracted, it has been reflected. That is what we call total internal reflection. As you can see, that one, that is refraction. The difference between that diagram and the other diagram is that you can see the light has bent there, but in the other diagram it has been refracted. So, for total internal reflection to occur, we have two conditions that must be obeyed. Number one, light must be traveling from a denser to a less dense medium. Number two, the angle of incidence must be greater than the critical angle. Total internal reflection cannot occur when light travels from a less dense to a denser medium like air to water or water to glass. In such cases, refracted rays are always obtained. And what is the relationship between the critical angle and the refractive index? As we can see, sine C, that is, C is the critical angle, is equivalent to 1 over the refractive index. That means the refractive index, N, is the same as 1 all over the sine C, which is the critical angle. Therefore, N is equals to 1 all over sine C, where C is the critical angle. And that is the end of our lesson. I have an assignment for you. Number one, describe how you will calculate the refractive index using the critical angle. Number two, what is the critical angle? Our reference book is KLB Book 3, 5th edition, Physics, 2019. For more information, contact us on our phone number, YouTube, Elimu TV, Facebook, Elimu TV, and Twitter at Elimu TV_KE. Thank you for watching Elimu TV. Stay tuned.